Me that email reminded me last night. Alrighty, so we are going to answer questions on section 7.1, and then we're going to cover section 7.2. So yeah, alrighty, so it is 1/27. Where is January going, man?
January of 2020 felt like it lasted forever.
Yeah, it's flying right by. Alrighty, and this is SM2H Unit 7.2. This is 5th period, and our objective is going to be able to... What? Well, I said that, but then nobody said anything, so I thought, well, maybe we're good.
Yeah, we're good.
Shh. Quiet. Okay, so you go 1.
How do you do n squared minus 6n equals 0?
Factor out n.
But like, how do you factor out if
Just take out an n, just an n. Then you've got n times n minus 6. Then there's your 2. Wasn't there one similar to that on the test?
Yeah, no problem.
Alright. Does that... Now we good? Okay. Alrighty. So, objective. Now I gotta erase my funny 18. Which only like 4 people got the joke, but that's okay. So we need to be able to properly describe and graph exponential growth Yeah, anything in the pumpkin's available. I don't know if you want to steal it, but you could use it, sure. Yeah. Exponential growth and decay. Now, this stuff's a little different, gonna be honest, because it's something that I don't think you've seen the equations for very much. Now, what you typically have is you're gonna have an equation that looks like this. Y equals... And then usually it looks something like this. A times b to the x. Okay? Now, what you end up with is b determines what kind of function it is. Okay? If b is greater than 1, it's a growth function. Okay? If b is less than 1, it is a decay function. Now, from there, there's going to be a lot of things that can change. So, for example, if I had y equals, now you don't always have an a, and in fact, I don't think any of the ones we do today have an a, simply because it's kind of our first foray into this. Down the road, they will. So let's pretend for right now that a is always a what? A 1, right? So I'm going to have 1 times, then I'm going to have b. Then watch what I do here. X minus h plus k. Now, as I look at that, that should kind of do what? No, but I heard it. It should look familiar because we've seen something that looks kind of like that, right? Now, again, this number up here, this is going to be a what? I got 2 kinds of... Now, okay, that's actually a great point. Let me show you something. And if you recall, I suggested you get one of these, and if you have one of these, it's going to make this a lot easier. Now, let me show you what happens here. Let's say that I want to do a growth function, right? So let's just make a b of 2, just to make it easy, right? So what you're going to have is you're going to have y equals 2 to the x, right? And I'm going to graph that sucker. And I've got to zoom this sucker. So let's go window, and I'm going to have my y min be -5, and I'm going to go up to 25, and I'm going to go by 5s, and let's graph this sucker just so we can get an idea of what's going on here. Okay, so there is That is what an exponential growth function looks like. Okay, and that's your standard, just kind of your base function, right? Now, down the road when we get into some other types of things, this will be what is referred to as your parent function. Okay? It'll be kind of what the base function looks like, right? And then these are going to become my what? What did we call them the other day? Starts with an S. I have a horizontal shift and I have a vertical shift. These are going to become my shifts, right? So now let's say I take the same thing and I'm going to go down and I'm say, okay, now I'm going to go to the, except now let's put a shift in there. So let's say I went x plus 5. Okay, now I graph this. Notice, what did it do? It shifted to the left 5. Okay? Is that what we would have thought would have happened? No? Maybe? Well, where is that? It's in the parentheses, right? Well, what does it usually do when it's in parentheses? Goes the opposite, right? Also, the one in the parentheses was my horizontal shift, wasn't it? The one outside the parentheses is my vertical shift. So let's go and do the same thing now, except let's just go 2 to the x. And now let's go down and let's go plus 5. So now this should shift me where? Up 5, right? Let's go to graph and see what happens. Does it do exactly what we thought it would? Yes. So when I look at this, is this really that much different than what we've done before? No, the only thing that's changing is the type of shape I'm going to have, right? So if I gave you this, y equals 3, x plus 4 minus 7, okay? And I said, let's graph that sucker. Now, I don't expect you to do this, but I do want to show you what it should basically look like. If you were going to draw this, and what some teachers will have you do, and I'm going to be honest, I really don't care, is they'll have you draw the parent function, okay? The parent function is always, it's always going to look something like that. Always, because it's a growth function. Now, typically, if that was a 2, that's what it would look like. Now, because this is a 3, anybody know what that 3 does to it? I heard it. What? Yeah, who said that? You said that, Kent? Right, it's going to make it steeper. You're right, that's going to make it steeper. I almost wrote speeter. Change the P and the T. Yeah, no, not nice, but whatever. It's going to make it, is that how you'd spell steeper? Is that a word? Yeah? That'd be stepper. That wouldn't even be stepper, because I think stepper has 2 P's. You think it'd be S-T-E-A? See, I don't know. It doesn't matter. I don't care. Now, you're right, though. That's going to make it steeper, right? It's also going to shift me where? Left 4 and down 7, right? Now, I'm going to go left 4 and I'm going to go down 7. Now, what you need to understand is that this value right here, okay, if you go back to any parent function, okay, this value is always going to be, not always, but for what we're going to do right now is going to be what? Does anybody know? It's going to be 0 and it's going to be 0 and 1. Because if I go back to my parent function, which was y equals 2 to the x, when that is 0, right, anything to the 0 power is 1 except 0, right? So in this case, 0, 1. So basically what I could do is from that point, I'm going to go where? I'm going to go left 4 and I'm going to go down 7, right? So I'm going to go left 4 and I'm going to go down 7. And where's that going to put me? It's going to be negative what? Negative 4 and negative 6, right? Okay? Right? Because I was at 1, right? Now another thing you end up with is what this is. Let me show you something really quick. Okay, now, right here, you end up with something called an asymptote. Okay, has anybody ever heard the term asymptote before?
No. Yeah.
Yeah? Do you know what it is? Well, let me share with you a funny story. Yeah.
It's the line, that line will never stop.
Okay, so it's a What's so funny, Palmer?
It was a memory from last matches.
Well, share it with us.
Betsy Splash called him asymptote.
Okay, well let me share with you a funny story, Palmer. Let me take you back to the class of 2003. Okay? None of you were born?
No.
Oh, damn. That was a long time. So anyway, the class of '03. If any of you know Coach Baird, this was his class. Okay? There were probably 7 of the most immature boys I've taught in 23 years. And they were all in the same class. All of them.
Awesome.
Yeah. Coach Story's little brother was one of them, in fact. And I will never forget the first day I said asymptote. They're like, oh, you know how teenagers are. Class was over. We were done. Every time I would mention, oh, Mr. Denton said ass, you know. So guess what I did?
You made it asymptote.
I made it asymptote. And ever since then, that's what I've called it. Because of boys like you that just giggle, 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 giggle. Because the minute I said that, I knew what was going on, Palmer. See, I'm a thinker. Okay?
But it's funny.
It's funny until you can't teach the class anymore.
Yeah, but it's still
Right? So, now, if this is my parent function, okay, I have similar to what would have been my vertex, right? I'm going to go and graph this. Now, if this right here is my y equals 2 to the x, okay, how is my graph, besides the fact that I've moved it, which is called a translation, I've moved it, what is my graph going to do, Kemp? It's going to be, you said this, it's still steeper because this one had a base of 2, mine has a base of 3. And all you're going to get is it's going to look, and to the naked eye, you probably wouldn't even know the difference. You know what I'm saying? But it will be kind of like that. And that's what it's going to look like. And you can tell that this line is steeper than that line. Does that make sense? Now let's go and look and see what we got here. So if I go back to y equals, and I still got that in, so we can clear that out, we can clear that out. So we go back, here's my parent function, right? Okay, so that's my red line. Oh, let's move this down so we can see it. There we go. Now let's go and type in the other one. We were 3 to the x, what were we? Plus 4 minus 7, right? Close my parentheses, minus 7, right? Uh-oh, I didn't open parentheses, dang it. Second, insert, left parenthesis. Oh, I'm going to have to adjust my window, aren't I? Now, clearly I didn't go steep enough fast enough, but I think we'll get the idea. Let's go -10 here. So my blue one's my parent, right there. And then here comes mine. Notice I've went left, I went down, and clearly I did not get what? I didn't get steep enough fast enough, right? But we see clearly that my line is steeper than the original line, okay? And that's what they're after. And I'm going to be honest, freehand, just make it look like it's supposed to. As long as it looks generally right, you're going to be okay. I would, though, make sure, this kind of goes back to a couple of questions on the test. Notice you got to do what? Label things. If I was not sure if my graph looks good, what would I write here? Yeah, I'd probably write steeper. Just to make sure I know you know that sucker's a little steeper than the original. Does that make sense?
Yeah.
Now, let's look at a decay function. Okay, a decay function. Now, decay, all it changes is that my B is what? No, my B is less than 1. Now, negatives change things. So when I'm talking less than 1, it's kind of like what we did with parabolas, right? I'm talking about just the what?
The number.
Just the number, not the sign changes things, flips them. Yep. So we're talking a fraction less than 1. So if I had, let's do 2 of these. Let's say y equals 1/2 to the x, right? And then let's go to y equals 1/2 to the x minus 3 plus 2. Okay? So, let's draw this top one, y equals 1/2 to the x. Well, what does a decay function look like? Yeah, it goes backwards, right? Because it starts big and then gets smaller, right? As it decays. It's like what? Anybody know of a decay type function in real life? Say that again. Okay, but you're right. I mean, anything that does that, fruit, anything that dies, you're right. But I'm talking like radioactive decay. Nobody knows what that is? Like half-lives, things like...
losing electron.
Yeah. Like me and these two are the only ones that know what half-life is. I mean, you have something that radioactive decays.
Oh, we talked about this last year in some class that I wasn't paying attention to.
Uranium, when the substance
It was
starts
like,
to
was it
break
like
down.
daughter isotopes or like that?
Yeah, I mean, it's got isotopes, all those things. So you must have heard something.
Yeah.
You just didn't pay very good attention.
Well, yeah, it was just really confusing, so I just blocked it out. And then I failed the test.
That'll do it.
Whatever. I'm just going to shut up now. So, 1/2 to the x, again, is going to be 0, 1. And it's going to look something like that. Again, this line right here becomes my what? The x-axis becomes my asymptote, right? Now, what am I going to do? I'm going to go where?
Up 3.
No, I'm going to go
Left,
right 3 and up 2. So I'm going to go right 3 and I'm going to go up 2. So right 3, up 2. Now, I have a new what? I've got a new asymptote. Where's that new asymptote at? Anybody know?
It's just going to be right where that dot is.
No.
Be 1 down.
That dot's where I'm going to cross. It's 1 down from that. It's always at this number. So now it's going to be at 2 because that points at what? Points at 3 now, right? Actually, wait a minute. That point is at 4, right? So I started at 0, 1. I went right. No, it's at 3. Because this was 0, 1, right? And I moved right 3 and up 2. Doesn't that put me at 3 and 3? Right? 3 and 3. Which means my asymptote, this, is also known as your horizontal asymptote. Okay? So, right here, got my horizontal asymptote. Now, my base is the same, so my steepness would be the same. I've just moved it, right? So I'm going to try to make it look pretty much the same. And it's going to look something like that. It has just now been shifted to the right and up. Okay? Are we seeing that, or?
No, I'm like super keen on it.
Yeah.
Like,
Isn't
how
it
do you
always
get all
at
the
0,
numbers
1?
And like, how did all this happen?
Your parent function is always going to be at 0, 1. Always.
So for decay, the parent function is 1/2 x.
For decay, it changes a little bit, but you could use that. Okay, just to understand again, all that does is change how steep that line is. They're all going to look about the same. The only reason I chose 1/2 is because we used 2 for the other one. If we would have went with 3, I would have chosen 1/3 probably. But all that third does is make it less steep. Yes?
So the 1/2, like in parentheses, it doesn't change anything, right?
It changes ultimately how steep you are, but that's it. Yeah. This will always be 0, 1 as long as there's no what out here. As long as there's no shifts. You know what I'm saying? As long as there's no H and K. If it's just a base and X, it's always going to be 0, 1. And then I'm going to move it. Now, understand, I really don't care if you draw the parent function. I'm just trying to show you how what we do changes from what it would have been. Okay? So let's do this. Let's go here. Let's go y equals 4 to the x minus 1 plus 5. So say I've got that. Now, if I were to say, okay, let's compare these two. Now, standard parent function would have been, let's just say it's y equals 2 to the x, just general, right? So we've still got, that's at 0, 1. I'm still going to look.
Wait, why is it decay?
What?
Why is it decay?
Ah, shit, it's not. What was my equation?
4.
4x minus 1.
And then let's go y equals 2 to the x, right? 2 to the x, not 2x. Okay, so again, I've got 0, 1. I know I'm going to look something like that, right? 0, 1. Okay, now, where is the asymptote going to be for my new graph? It's going to be, no, my new asymptote is going to be at, my new asymptote, that's that horizontal line. It's going to be at that value. So I'm going to come up here. It's going to be at y equals 5. That's horizontal lines, right? Now, my new point is going to be where? 1, 6, right? So I'm going to go right 1, I'm going to go up 6, and it's going to be about right there, right? So I'm going to do this one in blue. It's going to be 1, 1, 6, because from 0, 1, I went right 1, and I went up 5, which puts me at 1 and 6, right? I know this line is a what? So that means I'm not going to cross it, so I know I'm just going to kind of mirror it. But I'm also a 4 here, so mine's going to be quite a bit steeper, right? So as I come across here, as I hit that point, I've got to get really steep really fast. And it's going to look something along those lines.
Okay, I'm like so confused.
It does. With what?
Okay, everything. Wait, so you did the 5, the last number. That's what is where the asymptote.
That's where the asymptote is right there.
So like that's like your y in a way. So like that's your.
Yeah.
Okay. But then where do you get the 1 and 6? You just add 1 to the 5.
No, I'm adding.
You're starting.
This is my x value, right?
Okay.
I'm at 0.
Okay.
I add 1 to that, I get 1. This is my y value. I add 5 to 1 and I get
6. 1 and 6. Yeah, but I don't get how. I don't get it.
you start at 0, 1.
You start at 0,
You start at
1.
0 and like,
It's just, you go up top.
so you just add the 5. So basically, you don't need the top numbers. You just need that number.
No, I added 1 because I was at 0.
Yeah.
X and Y.
Okay.
I add 1 to 0, I get 1. I add 5 to 1, I get.
6.
Think of it like that's your starting point, and it's 5.
Yeah, this is my starting point. I'm going to move right 1. I'm going to move up 5. That new point will be at 1 and 6. Yeah.
So on the last one, I didn't like do the bottom line. I just kind of put 0, 1, and I do that. Or can I just
Yeah, I don't care how you do it. I'm just trying to show you how it changes. Yes.
So why don't you start at 0, 0, and what is the point of the
Because you can't be at 0, 0. Because if X is 0, what is 2 to the 0? No. Anything, Steger, didn't you just talk about this? Anything to the 0 power is what? 1. Except 0. Then it's undefined. So, no matter what you have in a parent function, if X is 0, this is always going to be 1. 0, 1. Then from there, I'm going to move.
Wait, what if X isn't 0?
Then it's not.
What do you mean, what if X isn't 0?
Like, what if X was like 1?
It's not, though.
Yeah, like, okay.
So look. Okay, look at this. Think about it this way. You know what a T-chart is, right? Well, if X is 0, what is Y? 1. What if X is 1?
Y is, 0?
No, it's 1. Oh.
What is 2 to the first power? 4?
1.
2 to the first? Are you shitting me?
It's 2 because it's 2 times 1. No,
So I'm at 1 and 2. So what if X is 2 now?
Oh, yeah, because it's just 2.
Oh!
What if X is 3?
Well, wouldn't that change where the bottom line is, though?
No.
Oh my gosh.
You're talking this line?
No, the bottom of the 0, 1 thing.
No, because as X gets small, or as X gets negative, right? Let's look at this.
Wait, is it 2 seconds 4 though? 6.
No, because that is 6. That's 5. It's got to be below there, right? So this would have been 1 and 2. This would have been 2 and 4.
Yeah, you put 6 on the keyboard. Oh wait, no, that's a 4.
That's a 4. You just can't. So watch. This ain't that hard, people. Watch. What if X is negative 1? What's it? X is negative 1. So I got 2 to the negative 1. What is that?
Negative 2.
It's actually negative. Is it 1/2?
Say that louder, Steger.
1/2.
It's 1/2.
Oh my gosh. How?
So what if X is a negative 2?
Oh, so it's 1/4.
And what am I going to do? I'm just going to get closer and closer
But do you
and...
ever actually cross the middle line?
No, did you not pay attention to what Starkey said like 12 minutes ago? What did you tell him an asymptote was?
It's the line that you.
It's a line that it approaches but never crosses. Which is why as you see this, it's going to get closer and closer and closer and closer and closer, but it's never going to touch it. That's why they call it an asymptote. Nobody pays attention. Because he said those exact words like, I don't know, maybe 12 minutes ago, maybe 15. Yes.
I was just like wondering what if B is 1? Is it like a straight line or is that not possible?
Yeah, because 1 to any power is 1, so it doesn't change it. That's why. It's got to be greater than 1 or less than 1. It can't be 1.
So if you want
Okay.
to, that could be like how you graph the
Yeah. Yeah, you could. Okay. Now, let's look at this. We're not done. We're not even close. So let's see. We got that. Now let's graph this one. So we went 4 to the parentheses x minus 1, right? Close my parentheses, drop that down, plus 5. And let's see if it looks somewhat like what ours did. So there's my parent function. And here comes my new function. It's coming across right there. Pretty much just what we said it was going to do. I do what I can. You got a question? Are you doing your hair? Oh, okay. Alrighty, now that's that. Now the back side. Okay? Now we need to talk about actual word problems. Okay?
Yeah, this is a problem.
Now,
Yeah.
Wait, quick question real quick. Wait, so what makes it go decay over there? Is it like a negative on outside? Okay, sorry, I'm just making sure. I'm gonna write that down.
well, why didn't you write it down? Why didn't you write it down when I wrote it down the first
I
time?
did, and then I forgot that I was that. So we're good.
Okay. Alright, now. Okay, so now what they're going to do is they are going to do some word problems. Now, typically, most students struggle with these simply because the minute they see word problems, they go, oh, that's too hard. It's not. And look, everybody look at number 8, okay? We're going to do number 8. We're just going to change the numbers, okay? So we're going to do 8.
But it's not 8.
With different numbers, okay? Now, number 8 says each day, okay, we're going to make this 20%. So 20% of a certain drug dissipates. Okay, does anybody know what that means? Goes away, right? So right now I know that this is a what? It's a decay function, right? Now, so already I know that this is decay. So I have an idea in my mind already what this graph's going to look like. Okay? Now, so it says classify the function. We've already done that. Okay? Now, identify the growth or decay factor. That's my B. Now, this is where you got to pay attention. Instead of putting this as a fraction, they've written it as a decimal. Now, understand, that's how much I do what? Okay, I don't know who said that, but that was... So I'm going to decay by 1/5, but I need to know how much is still there. Yeah, it's the 4/5, or I could say what? Which is 0.8. 0.8 is left. Okay? Now, so this is my B, right? So when I were to go to write this in an equation, I would have y equals 0.8 to the what? To the x. Now, the next part says how much of the original amount remains after, let's say, 12 days. So how much is there after 12 days? Well, what do you think the 12 is? No. No.
That's your, would the 12 be your...
Say that louder, Palmer.
X, right?
Yeah, the 12 is the x. Okay, because that's my input. The value I get out after I do that math is going to actually be what? That's going to be what is left. So what I would have is I would have y equals 0.8 to the 12th. So if I go back to my calculator, I'm going to go 0.8 caret key 12. It's going to give me 0.0687, right? because they gave it to me in a percent, they're probably going to what? Want it in a percent, right? Well, that's going to be what then? 6.9% if we want to round. So after 12 days, there's only 6.9% of that drug in my body, right? Which means it's probably not being very what? Not very effective, correct? Now the next part says, if a second dose should not be taken if more than 50% of the original amount is in the system, when should the label say it is safe to redose? Now, so I've got to go and figure out where this value is less than 50. Now, there's like 2 or 3 ways I could do this. What would be the easiest? Richards. So I would say 50 equals 0.8 to the x, and then solve for x. Okay, so, but here's my question. You're on to something here. Problem is, does anybody know how to solve that?
You have to get rid of the x, you have to use the radical.
Nah, so look. Whenever x is an exponent, you have to use what are called logarithms or natural logs, and we haven't shown you that yet. Okay? Which means this is a great idea, but we haven't learned how to solve that yet. Okay? And I'm not going to show you today. Now, what else could I do? She's on to something here.
Yes.
I could
Like, T-chart it.
T-chart it, right? T-chart always works, doesn't it? So if I go here, and I go x and y, well, watch. If x was 0, what is y? 1. What does 1 really mean?
Like,
100%, right? So in reality, this 50 should have been a 0.5 or 50%. Does that make sense, Lindley? Now, we also know that 12 is 0.069 if we're looking at it without percentages, right? And I need to figure out where I'm going to be at 0.5, right? Well, I know it's got to be somewhere in there, right? So couldn't I just go and say, well, let's look at it. So I got 0.8 to the third. Whoa. I've never seen that before. No. No. That's an I. So at Q day, I'd never seen that before. Oh, I must have hit second. Oh my heck. Puts an I in for me. I'd never seen that. So we have 0.8 and somebody said third, right? And I'm going to get, so at 3, I'm at 0.512, right? So I'm at roughly 51.2%, right? So guaranteed that if I go 4, I'm at 0.4096 or 40.1 or 41% roughly, right? So it would have to be any day when?
between 3 and 4.
Yeah, after day, no, after day 3, wouldn't it?
Because so you're still above.
Because at 3 I'm above, but after 3 I would start to go below, right? If you wanted to be exact, what could I do?
You could split it into hours.
Now watch. What if I did this? We did this once before, so we were 0.8 to the x, right? Graph that sucker.
Is there a trace function for this?
There's anything you want, but I'll show you something even better.
That is a straight line.
Okay, so obviously decay like we talked about. Watch. Go second table. And we need to be right there. See how 3, you can't see that, but 3 says 0.512, 4 says 0.4096. So obviously it's between day 3 and 4. You could change that and go second table set. Watch this. And change that from 1 to 0.1. And you could go back to your table. And now it complete, and you could scroll down and you could find to the decimal when that sucker is going to be. We want it to be just less than 0.5, right? So it would be Yeah, 3.2 days. If you want to be exact. Because that's the first time it's below. Because 3.1 days is 0.5007. 3.2 days is 0.4896. So if you were going to be exact, you would say 3.2 days.
Do you want us to be exact? Or
I would just say between day 3 and 4, something like that.
Thank you.
I'll teach you. I mean, eventually we're going to do it exactly how Lindley suggested. And I'm going to teach that. It's just not today.
Like tomorrow.
I don't think it's even tomorrow. It is. Actually, I don't think it's till next unit that we get into logs. What? No, you can't use a radical. Because the only way to get an exponent down is to do a log or a natural log. And it'll screw everybody up, so don't worry about it right now. Okay? Palmer, did you just throw something in my class? Dude, we're in high school. We don't throw things. Yes, I'm all right. I just made something up. So it said it decayed by 20%, right? So what you would have had is you would have had y equals 100 minus 80, or 100 minus 20%, because that's how much it goes down, right? Which gave me 100% minus 20%, which gave me 80%, which is 0.8. That becomes my base. That becomes my B in the problem. So if it said it grew by 25%, what would it be?
0.75.
No, if it grew by 25%, it would be, Author, 1.25, right? If it doubled every day, then it would be, which would make it 2. You see what I'm saying?
So when it's decay, you
Subtract it.
you find the difference?
Exactly.
Okay.
When it's growth, you add it. Exactly. Okay? Let's try it. Okay, get busy. And then obviously there's some review ones at the end, but I don't need to teach them.